All right, today we're going to continue working on lesson 2.5, three-dimensional figures. Today we're going to focus in on volume. Yesterday you worked exclusively on surface area. Today we're going to work on the volume of the same types of figures that you found surface area of yesterday. Um, so volume by definition is the amount of space that's occupied by a three-dimensional figure. So if you were to open up the three-dimensional figure and fill it, the question is how much space is in there. And when we calculate the space inside a three-dimensional figure, we give our answer in cubic units. So what we're saying is basically how many cubes of a certain dimension does it take to fit inside a shape. So if you think about, just a basic, like a tissue box or something, uh, we're going to try to find out how many, let's say, inches, cubic inches fit in there. So you're looking at a cube that's 1 inch by 1 inch by 1 inch, and how many of those could be fit inside that box. And that's what we're looking for when we find volume, no matter the shape. We're trying to find how many cubic units fit inside. All right. One good way to look at it to start with is to look at some shapes that are made out of what we call unit cubes. So, and this is a nice way to explain how we find volume, I think, is to look at the unit cube. So let's look at the first one here on the left. All right. We want to find the volume. Again, volume is how much space is inside this shape. Okay. It's not actually a cube because the dimensions are different, but it's a three-dimensional shape. It's a rectangular prism. All right. So the first thing we'll do is we'll look at the bottom layer. So if I look at the bottom layer, this thing is 4 by 3. So if we were to look just at the bottom layer here, there'd be 12 cubes that fit across the bottom. Okay. And then the way our formula works for volume is how many layers of those 12 cubes do we have? Because it maintains its shape the whole way up. So we got 4 layers of 12 cubes each. So we have a volume of 48 cubic centimeters. That is 48 1 centimeter by 1 centimeter by 1 centimeter cubes are what's stacked up right here. Okay, so let's move over here. Same kind of deal. Now a little different because we got this little piece on top, but the bottom layer is 3 by 4. So on the bottom layer, we got 12 cubes laying there. Now we got 3 layers of 12 cubes, right? So we got 12 cubes times 3 layers. That's 36 cubes here. And then in this case, we got an additional 3 stacked on top. So the volume of this shape would be 39 centimeters cubed. So that's a kind of a nice visual of what we're actually finding, how many cubes fit inside a shape. And it's also kind of a look into how we actually do our calculation when we find volume. Okay. So first of all, here's a rectangular prism. Okay. And this is a standard kind of rectangular prism. Over here, we got another rectangular prism. This is what we call oblique. Oblique is when it seems like the shape has been tilted. So, if you look here, you get this angle right here. Well, it looks like we've taken a rectangular prism and kind of knocked it out a square, if you will. All right, so this is oblique. The congruent bases are the bottom and the top, and they're just not directly above each other. That's another way to look at it. We calculate the volume of a oblique prism just like we calculate the volume of a square prism. Okay, when I say square, I mean right angles. All right, so how do we find the volume of a prism? Well, the formula is pretty basic, and it's generic in that it says the volume is equal to the area of the base. That's what the capital B represents. Area of the base times the height of the prism. Okay, so you have to identify the base shape, find its area, and then multiply by the height. Now, the height of our prism is always going to be the distance between the two base shapes. All right, let me show you. So I always start with the formula. Volume equals area of the base times the height. So the base shape, the way this thing is setting, are these two rectangles, top and bottom. Okay. So those rectangles are 3 by 9. So how do you find the area of a rectangle? Length times width. So my area of my base shape is 3 times 9. Okay. The height of the prism is the distance between the two bases. The distance between these two bases is 9. Okay. So my volume is now going to be calculated by going 3 times 9, which is the area of the base shape, times the height, which is 9, multiply it together. It's going to be 243 centimeters cubed that fit inside this shape. Okay. Over here, look at the oblique one. We're going to start the same way. Okay. What's our base shape? Well, our base shape is a rectangle. Okay. 4x9, that's a rectangle. This up here, also a 4x9 rectangle. So area of the base, when it's a rectangle, is length times width. So the area is 4x9. Now the height here is where you got to look into it a little bit. The height is the distance between the two bases, and the distance has to be direct, a right angle distance, okay? Distance from top to bottom. That's this over here. So the height of this one is 7. So then 3 times 9 times 7, 189 centimeters cubed. That's the volume for this oblique rectangular prism. All right, so we calculate them the exact same way. Okay, how about finding the volume of a triangular prism? They name it a triangular prism because the base shapes are triangles. So you got to read into that, okay? Well, we find the volume of a triangular prism the same way we did a rectangle. Area of the base times the height. The difference here is the base shape is a triangle. This triangle, these are the two bases, okay? So this shape is actually laying on its side. It's not on setting on its base. It's tipped over on its side, okay? So I got to find the area of this triangle. How do I find the area of a triangle? 1/2 base times height. So this triangle has a base of 5 and a height of 7. All right. So what's now the distance between the two triangles? Well, the distance between the two triangles, that's considered the height of the prism. If we were to tip this thing up on the triangle, you'd see this is the height. So our height here is 9. All right. So area of the base, 1/2 5 times 7 times the height, 157.5 centimeters cubed would be the volume of this triangular prism. Okay. Formula starts the same here, right? But it changes because the base shape's a triangle, and here's how you find the area of a triangle. All right. So that's how it's different than a rectangle, and that the big B was a different formula. Okay. How do we find the volume of a pyramid? Okay. Well, again, we got a formula for this. It's 1/3 times the area of the base times the height. Okay. So if you look at this, okay, our base shape is a rectangle here, but the rectangle doesn't have another rectangle above it the exact same. It actually goes from a rectangle to a point. So it's getting smaller as we move up. All right. And what the relationship is, it's basically 1/3 of what this would be if it was a rectangular prism all the way up. All right. So we just got to follow the formula. So it's 1/3 times the area of the base shape times the height. So the base shape we just established was this rectangle. How do you find the area of a rectangle? Length times width. Okay. The height of the prism is the distance from the top of the prism down to the base that's perpendicular to the base. So it's got to be a direct line. If you remember, you could have what's called a slant height too, that kind of slides down the side. That's not what we want. We want like this. If this was a tent, this is the pole for the tent that holds it up. Okay, that's the height. So our height here, distance from the top of the pyramid down to the base is 9. So we're going to plug 9 in place of height. And now we're just going to multiply all this together. So I would do, if it was me in my calculator, 8 times 5 times 9, hit enter, and then divide it by 3. Because when you take 1/3 of something, you divide it by 3. That's 120 centimeters cubed. So the volume of this is 120 centimeters cubed. Okay, just got to follow the formula. All right, so now we're going to find the volume of cylinders. Okay, so if you look at this, this is what we call kind of like a square cylinder because the sides of the cylinder are square to the base. This is oblique. Again, it's been knocked out of square, so to speak. It's been pushed over. Okay, we still find the volumes the same way. How do we find the volume of a cylinder? It's actually the same formula as a prism. Area of the base times the height. But since every cylinder has a base that's a circle, we can just go ahead and write this. Every base is a circle. How do you find the area of a circle? Pi r squared. So the volume of any cylinder is pi r squared, area of the base, times the height of the cylinder. Okay. So there's my formula. Volume equals pi r squared h. Okay. There's my two bases, these two circles. They both have a radius of 4. So I'm going 3.14 times 4 squared. What's the height of the cylinder? Well, it's a distance between the circles, just like the height of the prism was a distance between the two bases. Okay, so my height here is 7. Okay, you got to square the 4 first. The square is not applied to the 3.14, it's only to the 4. So 4 squared, then times 3.14, then times 7. And if I go back up here, it says round your answer to the nearest whole number. So this is what I would get if I multiplied all of it together. Nearest whole number means to the ones position. So that 6 is telling me to round this up to 352 feet cubed. And I put approximate here because it's a rounded answer. Okay, so let's do the oblique one here. Well, it's the same concept. Area of the base times the height. Base shapes are these two circles. Okay, so we're going to go now. One thing to notice here, they're giving you a diameter. Diameter is 12. That means radius is half of that 6. I have to use radius in this formula. All right, so next step, I got 3.14 times 6 squared. Now the height has to be the distance between the two circles, the perpendicular distance. So that's going to be this 10 right here. Okay, so the height's 10. So again, in your calculator, 6 squared is 36 times 3.14 times 10. Okay, and do all that multiplication together, I get 1,130.4. And then they said round to the nearest whole number. So we're going 1,030 feet cubed. Okay, oh, actually, I'm sorry, meters cubed, that should say. Okay, but they said round to the nearest whole number. That's your ones position. 4 is not enough to round it up, so we round it down. And again, I show approximate here. Okay, so that's a cylinder. We can also find the volume of cones. And a cone is the circular version of a pyramid. Okay, so if you remember for the pyramid, it was 1/3 area of the base times the height. Well, it's the same deal here. All right, except now, since every cone has a circle base, I can go ahead and put pi r squared in place of the area of the base part of the formula. Okay, so volume is 1/3 times pi r squared times h. Okay, our base shape is the circle. It's got a radius of 4, so I'm ready to plug that in. Okay, 1/3 times 3.14 times 4 squared. Height has to go, again, it's like a tent pole. It's from the top of the shape, top of the cone down to the base. Okay, so the height is 9. Now I'm doing this all at once in a calculator. 4 squared, that's 16. Times 3.14 times 9, hit equals. Divided by 3, that's what it means, take a third of it. 150.72 centimeters cubed. Back up here it says do not do any rounding. So got to follow those instructions each time, guys. 150.72 centimeters cubed. So that's how we find a cone. The last one is a sphere. So to find the volume of a sphere, okay, it's 4/3 times pi r cubed. That's the formula. And we're just going to follow that formula and plug our information in. Notice here it says the diameter of the sphere is 16.8 meters. Okay, so if the diameter is 16.8, that's the distance all the way across. That means the radius is 8.4. This is what we need to use in our formula, 8.4. All right, so we start with our formula. I mean, the only thing I got to plug in here is radius. We know pi is 3.14. Now we got a radius of 8.4. So I'm going to plug everything in. Now let's go back for 1 second. Round your answer to the nearest tenth. Do not round intermediate computations. What does that mean? Well, that means, for example, if I was to cube this 8.4, okay, I'm going to get 592.704. What this means is don't round this to the 10th. Leave every bit of this number. Finish your calculations, because you got a calculator doing it, and then round at the end. Okay, so you only round once, and that's the end. So I'm going to take this 592.704. I'm going to multiply it by 3.14, hit equals. Okay, now I'm going to multiply that answer by 4, hit equals, and then divide it all by 3. Okay, so you're going to multiply it all by 4, then divide by 3, and round to the nearest tenth. I get 2,481.5 meters cubed, following the formula. Okay, so that's all of our volumes. Okay, there's additional examples and there's more explanations on in your McGraw-Hill online textbook. You can go to this section and look, and it'll give you more information. Make sure you're writing down the formulas, guys. Make sure you're writing down the formulas and have them sitting right next to you while you're doing the problems, and use them. Okay, that's the idea of having them, is that you can use them. All right, so make sure you're using those. Make sure you're writing out the work. Don't tell me you didn't have to, because everybody thinks about the process that they're using to solve. All you're doing is writing down the information. Get in the habit of doing it. show the work, and make sure you have that ready to turn in class. All right. All right. I'll let you get at it.